everyone, and welcome to today's class on demand planning. I hope all of you are doing well. So in today's class, we are going to be focusing on three topics. The first one is demand forecasting. The second is time series analysis. And the third one is calculating errors in forecasting. So without further ado, I'm going to now start our class for today. So for the first topic we'll be covering is forecasting. Now, for those of you who heard my first lecture on demand planning, um, we discussed in it that there are three main questions that are asked as far as, figuring out demand. And the first thing that needs to be done is you need to do demand planning. And what I mean by demand planning is you need to figure out exactly what product, at what price, using what promotion, and where you're going to place that particular product that you want to make so that it sells. So you need to plan, you need to look at the market, do a competitive analysis, and come up with a particular product and a product mix that will really click in the market. That is all about demand planning. Then next up is demand forecasting, and that is what we'll be focusing on in today's lecture. And in demand forecasting, we discussed previously that there is strategic, tactical, and operational forecasting. This was something I covered in the last lecture. I'll also be talking to you a little bit more about it in the next slide. Also, generally speaking, when people make forecasts, they make a baseline forecast. They say, okay, this is the base. They make an upward forecast and a downward forecast. And usually they make one that they think is very realistic and they follow that one. Once you have a good product that's going to, really click in the market, demand forecasting really helps you figure out how much of the product you should make. So you don't want to make too much of a product because you'll be stuck with excess inventory. You also don't want to make too little of a product, because if you make too little of a product, you will run into a situation where there is a shortage, and your customers may not be motivated to come back to you again if they face a situation of shortage. Finally, you need to do demand management, and this is all about managing demand and supply. And so once you have a good product that's going to click in the market, and you have decided how much of a product you're going to be making based on your demand forecasting, you want to make sure that you continue to do good forecasting to balance the demand and supply. Also, that you have a good sales strategy and a distribution strategy, so that the product that you are making is easily available to your customers. So these are kind of the steps that are involved in demand, in the demand process. Forecasting is done at three different levels: the strategic level, which is long-term; tactical, which is more medium-term, quarterly or monthly, weekly; and also short-term, which is operational in days or hourly, daily kind of forecasting. And this slide I discussed in great depth in demand planning part 1 lecture, and I also explained exactly when you do this kind of forecasting using an example. So if you want to brush up, or if you've forgotten by any chance, you can definitely hear that lecture again to get more details on this particular slide. Next up, I want to talk to you, and it's very important for you to know that is in terms of forecasting, there are two ways you can do forecasting. One way is using numbers, and that is objective kind of forecasting. And the other is subjective forecasting. And this is when you don't really use numbers. You are doing it just by speaking to people. And I'll talk a little bit more about what entails subjective forecasting and what exactly is within objective forecasting. But very important for you to understand what the difference between subjective and objective forecasting is. Again, objective forecasting, you are looking at numbers and you are forecasting based on those numbers. and subjective is without numbers. It is more of a qualitative method of doing forecasting. Now, within subjective, there are two types of forecasting methods. One is judgmental, and here basically that you can do judgmental forecasting by sending surveys to your sales force, and it's really trying to understand what customers want through the surveys. You can also bring in a jury of experts. So you bring in a group of experts and sort of talk to them about your product and say, you know, what strategy do you think we should use? How can we increase our demand? Those kind of things. And you can basically use that to help understand sort of your forecast. You know, and then there's also a Delphi technique. And in the Delphi technique, basically you are using experts. You basically bring a group of experts together. You ask them, you know, to answer a series of questionnaires that help you with your forecasting. You do several rounds of these kinds of forecasts, these questionnaires, sorry. And once you collect that information from experts, the questionnaire information that you have gathered, you get a good idea of, you know, forecasting. So that is basically, you know, the Delphi technique of forecasting. All right, next is experimental, and this falls within subjective forecasting. And here you basically are able to give you give surveys to your end customer to understand what their you know, how much they're planning to buy in the future. This gives you a very good idea. It's a method of forecasting. You can do focus group sessions where you bring in some of your customers, you get them to sit together and, you know, discuss the product and get their insights on, you know, forecasting. And this is, you know, again, forecasting group sessions. And finally, test marketing. And so you basically, you know, get your product, you give it to a certain small test market, a small group of people, and you see how they respond to it. And you look at their trend, their demand trends, and based on that, you make a forecast. So these are, you know, the subjective ways of doing forecasting. Now, let's talk a little bit about the objective ways of forecasting. There are two types. There's the causal / relational method of forecasting. Here you can use several models. There are econometric models. There are input-output models. You can also look at certain leading indicators of what's happening in the market in general for your type of a product. And that will give you a very good estimate and help you forecast. Finally, you know, another method, objective method for forecasting is the time series method. And here, basically, the whole idea is that past predicts the future. And you look at various trends, and based on those trends of the past, you predict the future. Now, in order to do this, there are some models that can be bought in the market, and you can sort of put in the information of the past historical information, and it will help you do the forecasting. So that whole idea is, you know, of using models to sort of predict the future, and is, you know, all the black box approach. So many times, you know, companies try and use some sort of a combination. They don't only use one particular type of forecasting method. They use a combination of subjective and objective. So this is something for you to keep in mind. Okay. All right. Now, next, you know, in this particular lecture, of these 4 different categories or 4 ways of forecasting, we really are going to be focusing on the time series method. So I'm going to talk to you a little bit about time series analysis in a greater depth now. So as I had just, you know, previously mentioned a little while ago, time series analysis basically it comprises of methods for analyzing time series data or historical data in order to extract meaningful statistics and other characteristics of data. So time series forecasting is the use of a model to predict future values based on previously observed values. So again, in a nutshell, what time series analysis does is it looks at historical data, it finds a pattern in the historical data, and it says that probably the same pattern is going to be followed in the future, and so predictions are then based on that historical information and pattern. So for example, if you look at this particular slide, there's a graph here, and you see an upward and downward kind of a trend. You also see that in general there is an upward trend, right? So it's not going downwards, it's not really flat. You kind of see that the demand here is kind of increasing. So if you had to make a prediction in the future, you may kind of think that either it's going to stay kind of level, because there were two levels and then it's increased, or you may say, no, I think it's going to increase slightly more, but you probably are not going to say it's going to decrease. And the reason is that you're looking at the historical trend, and you're forecasting based on that. If you look at economics, several economists do predictions of the future based on the past, and especially economic conditions. So if, for example, from 1949 all the way to 2013, you can kind of see various patterns, then they will, based on this, they will be able to predict what will happen in the future as well. They do this many times, and this is called, in economics, this is called cyclical movement. So, that's something that does happen in economics. So again, time series analysis is used across various different industries and also in economics. Okay, so the agenda for today's lecture is that I will be covering, time series components. I've kind of done that for you now. I'm also going to be showing you how to do cumulative forecasting, naive forecasting, how to do moving average forecasting, and I will be showing you some examples of each one of these. But before I do that, I kind of want to talk to you about something that is important. In time series models, a level model basically means that the demand stays constant. So if you look at it in mathematical terms, your demand is going to just be a constant, which is A in this term, in this particular equation. And plus there'll be some little error, so there'll be some sort of a small variation, and that is the error term. But a level model, the formula is pretty much just static, or A. Now, if there is a trend, meaning an upward trend, or it could be a downward trend, then the formula for that would be the second equation, which is A plus BT plus an error term. And A is going to be the constant, and B is basically the change, or the increase or decrease. So, so this is the change, and the BT is that change. Right? So at what speed, or at what level is there an increase or a decrease? And then there is an error term. Next is, a formula that I wanted to just show you. We will not be covering this in our lecture because this is a little bit more advanced. But if there is some sort of seasonality, then there is a different formula that is used to do forecasting, and that is, the trend multiplied by this forecasting factor. And there is, if you want to learn more about it, there's a method to, there's an equation or method to figure out what exactly this value is. plus some sort of an error term. Sometimes there's a mixed level trend seasonality, which basically means a sort of an increase and decrease happening in an upward trend. It could be an increase or decrease happening also on a downward trend. In that case, this is the equation. And again, I do not expect you to know this by heart, and you definitely, the seasonality bit you will not be being examined on, but it is important for you to understand that, when you introduce seasonality, then you have the forecasting method changes. And so if in the future you ever face a situation where there is some sort of seasonality, then you would know that, okay, you know what, the forecasting has to include, you should remember that the forecasting is probably going to need some sort of a forecasting factor involved in it, and you can't just do it the same way as a level or a trend forecast. Okay, moving on, I want to talk to you a little bit about the fact that time series, this method of doing forecasting, is used for mature products at an SKU level. So they usually, time series analysis is not used for new products. They have to be mature. In general, it is used for short-term horizon, for weeks, months, quarters, maximum a year. It's not used for forecasting for 10 years ahead. Not done for anything like that. And generally speaking, the demand of the item that you are forecasting should be independent, shouldn't be dependent on any other factor. So for example, if you are doing you want to find the forecast for the tires of a motorbike, then that is a dependent product, because the amount of tires that are sold depends on the number of motorbikes that are sold. So you can't use time series analysis in that situation. However, if you are just doing the forecasting for motor bikes, then you can use time series analysis because it is an independent product. So how do you do time series analysis? There are basically 4 simple steps. The first one is you look at the underlying model, you look at the historical data, and you try and understand and see if there is a demand pattern there. Then you estimate the values based on that pattern, and you do the forecasting for the future. And finally, you review the performance, you check the forecasting, and you adjust the model if there are some small changes to it, but you tweak it a little bit. But basically, this is the high level way of doing time series analysis. Okay, now that you've gotten a high level overview of time series analysis, I'm now going to talk to you a bit about how to do time series analysis in a little bit more detail. And I'm going to introduce to you cumulative and naive forecasting. And this is 2 methods of doing forecasting. Okay, so let's just kind of have a look at this slide, and I kind of want to just show you, what naive and cumulative forecasting looks like when put on a graph. So visually, you will get a good idea. All right, so you can see here in this graph, this blue line is the actual demand. It's going up and down, it's going up and down. So, blue is the actual kind of what's going on. Now, if you make a naive forecast, then the naive forecast is in red. And if you notice, basically, it's exactly the same as the real demand, but it's just a little bit delayed. So it's 1 period delayed. Everything is the same pattern, but it's just 1 period delayed. It's got the same amount of increase and decrease. So that's basically happening. Now, if you make that's the naive forecast, but if you decide to instead make a cumulative forecast, you see that it's a lot more relaxed. So the green line is the cumulative forecast, and you notice that it's a lot more relaxed. There's not a lot of increase and decrease compared to the red or the naive forecast. Naive forecast, you would say, you know what, it's nervous, going up and down, up and down. And the green, on the other hand, is a little bit more relaxed. So I kind of wanted to show you what these look like visually or graphically. And now I also want to talk to you a little bit more about what naive forecasting and cumulative forecasting is, using an example. Okay, so let's start trying to understand how to do naive forecasting and cumulative forecasting. And the best way to do that is with an example. So in naive forecasting, basically whatever the actual demand for was in the last period is the forecast for the next period. For example, if the demand was 63.35 in period 1 on or day 1, then the forecast for day 2 will be 63.35. Simple. Then again, let's look again and see what happens the next day. So the next day, the actual demand at the end of the day was 62.09. And if you are doing a naive forecast, you will say at the end of day 2 that you expect to be able to sell 62.09 in the following day, and so on and so forth. So again, just to repeat, whatever the demand was in a particular period, let's say period 3, the demand was 97.08 at the end of the day, that will be the forecast for the next period. So the forecast for period 4 will then be 97.08. So this is basically how you find the naive forecasts for any period of time, right? So that in this example, I have just completed the naive forecasting, and now I'm going to show, and it's pretty simple, right? So it's very, very simple. But the one thing you do need to remember is that if a question says, what is the forecast, what is the naive forecast for period 2, then the naive forecast for period 2 will be 93.35. Similarly, if a question says, what is the forecast for period 6, then in that case, you will say that the forecast for period 6 is going to be 263.98. So that's basically naive forecasting for you. And as I mentioned, you do need to be mindful about the fact that, this particular figure is the forecast for period 2. It is not the forecast for period 1. Period 1, you know what the demand is, and based on that, you have made the forecast for period 2. Now, cumulative. Cumulative basically in short terms means average. So for example, you have a cumulative GPA, and a cumulative GPA means what your GPA is, the average of all the grades that you have gotten over a period of time, right? So if your cumulative GPA is a good indicator of the average, how you've performed on average. Let's say at the end of 4 years, if you're doing your BBA, or 2 years if you're doing your MBA, and somebody wants to get a good assessment of what, overall how you've done, they will look at your cumulative GPA. So when you are calculating cumulative GPA for the first period, it is exactly the same as the demand. And so it is 63.35. It's the same. But for period 2, you actually take an average of period 1 and period 2. So average of period, the actual demand in period 1 and period 2, and that is 62.72. So that is what your cumulative forecast is for period 3. Now for period 3, if you are trying to calculate the forecast for period 4, you have to take the average like so, right? And if you want to put in a formula, this is how you would put in a formula. You just make B3 constant, and this is the formula, and then you can easily click and drag. And if you want to just double check, if this figure is correct, I can show you by quickly taking the average of all of this, and it is exactly the same. Now, I want this to be just 2 decimal points. So I'm going to make it 2 decimal points. So this is basically how you are able to calculate naive and cumulative forecast. Now again, if I ask you what the cumulative forecast for period 9 is, then it would be this figure over here. This is the average of the first 8 days, and that is basically what your forecast is for period 9. And that's basically how naive, and you can do naive and cumulative forecasting. So I hope that is helpful for you. Now, after that, I'm going to actually go back and discuss moving average with you, because that is also another way of doing forecasting, and it's very important for you to do to know how to do moving average forecasting as well. So in moving average forecasts, you include the last M observations. M stands for moving average observations. And this is a compromise. This isn't as nervous as naive forecasting, and neither is it as relaxed as cumulative forecasting. In fact, it's somewhere in the middle. And if you look at it visually over here, you can see that, this is the blue line over here is the actual, the red is naive, and that's pretty understandable. It's a mirror image, just a delayed mirror image. And then here in blue, we have a 2-period moving average. And so you see that the moving average, if it's a 2-period moving average, well, you get the first forecast you'll have is for period 3. And so period 3, and you kind of see it's kind of in between the naive and cumulative, the shape, right? And here you can see, this dotted line. This is a moving average period 4, again a bit more relaxed, and moving average period 6 is even more relaxed. So I think, now that I've shown you visually, you also, by the way, do have an example over here of doing naive forecasting, cumulative forecasting, moving average, period 2, 4, and 6. But I will show you in a little bit more detail how to do, how to calculate moving averages. So I'm going to now just share my Excel sheet with you. And here I'm going to show you how to do some moving average forecasting. So the first thing I'm going to do is find a moving average forecast for the 2-period moving average forecast. So for this here, I cannot, the first period will be left blank. And what I will do is I will take an average of just 2 periods, right? And this is a 2-period moving average, so I need to take 2 periods average, and that is 62.72. So this is my forecast for period 3. Now, once I've put this formula in, I can click and drag. And again, just to show, this 205 should be an average of these two figures. And I'm going to do a quick calculation just to show you that it is exactly the same. I generally like to have 2 decimal points, so I'm going to make this 2 decimal points just to sort of standardize it. Okay, next I'm going to do a four period moving average. Oops, there's a little bit of a spelling mistake. Let me just correct that. There we go. And so for a 4 period moving average, I will need to take a average of 4 periods. So the first 3 periods will be left blank. And I will go over here and take an average of the first 4 days of demand. And this is what it comes to. So again, the first 3 periods will be left blank, and this moving period, this 4 period moving average will give me the forecast for day 5. So my forecast, my 4 period moving average forecast for day 5 is 73.56. I can click and drag this, and I will be that these are the forecasts for the remaining periods of time. Again, I just want 2 decimal points, so I have made that adjustment. All right, next I want to take a moving average of 6 periods. So the first 5 periods I will leave blank, and in period 6 I will go ahead and take an average of all of these. So, and then again I can click and drag. And so period 7 is actually an average of 1, 2, 3, 4, 5, 6, right? So this is an average 3. If you take an average of these figures that I've highlighted over here, that will equal to 359.4067. And again, I kind of want to just make this 2 decimal points. So again, by doing this, I hope you understand, and I'll just repeat this for your information. If it's a 2 period moving average, all that means is that you need to take the average of the last 2 periods. So if, for example, you want to make a forecast for period 6, then you will just average period 4 and 5. If you want to make a forecast for period 10, that will be an average of the demand in period 8 and 9. So the last 2 periods you kind of just average out, and that gives you the forecast for the next day. And if it's a 4 period moving average, then you have to find the average of the last 4 periods, and it kind of, if you're looking, for example, period 5 is going to have the average of day 2, 3, 4, and 5. The average of all of these will give you 123.72, and this is the forecast for period 6. And the methodology is the same for moving period, 6 period moving average. So I hope with that you have gotten a good understanding of how to calculate forecasting, how to do forecasting using the cumulative method, the naive method, and the moving average method. I am now going to go back to our lecture and just talk to you a little bit more about moving average, right? Okay, so here again now, if you have to, this M, basically all of this is just showing you that you have to take, how to calculate, moving average, how to do moving average forecasting. And this is just, the mathematical formula. Now the question is, should you use 2 period moving average, 4 period, 6 period, 12 period? How big should M be? How many periods should you use? If you make it too small, that's not a good idea. Making it too big is also not a good idea. So you kind of have to find a middle way, and go with that. So moving averages, generally speaking, there is a little bit of a delay or lag. So that's something to definitely keep in mind. I have made this, for you, I've included this in the lecture so that you can just do a little bit of practice on your own. And, feel free to ask me questions if you have any questions or you need any clarifications. We will be having a question answer session, so you can definitely reach out to me and let me know. Now, this lecture is now proceeding towards the end. And I want to kind of talk to you about some truisms. And truisms are basically truths related to forecasting. One of the truisms is that forecasts are also wrong, always wrong. Now, this is interesting because, for example, weather forecasts. Nowadays, there's a lot of technology on forecasting weather. However, it's not always accurate. There are still mistakes that happen. And so this is actually the truth about forecasting. The past does not always predict the future. And so generally speaking, in order to deal with this issue, people usually have ranges. I kind of mentioned this a little earlier on in the lecture. Best case, realistic, and worst case. They usually have these ranges when they're doing forecasting, because they realize that, look, there may be some changes, there may be certain things that may not be being able to, that's not possible to take into account. There may be just some random events that happen. And so in order to sort of keep that in account, ranges are used. But it is important to remember that forecasting is not a accurate science. It is a general prediction. Also, another truth is that aggregate forecasts are more accurate. So if you have forecasts of if you take more things into account, more data into account while doing forecasting, your forecasts are probably going to be more accurate as compared to if you are forecasting using just two pieces of information. If you're just using two pieces of information, there's a big chance that your forecast is not going to be accurate. So the more information you use, the more aggregated your forecasts are, the more accurate they are. The next truism is that the shorter time horizon forecasts are more accurate, and this is true. If you are trying to make a forecast for 10 years or 50 years, that your predictions, there's a high possibility your forecast will not be accurate. But if you have a lot of information, and based on that information, you are trying to make a forecast for the next day, there is a much higher probability that your forecasts are going to be accurate. And this is very important. Generally speaking, companies try to use the method of postponement, and I discussed this in length in demand planning version 1, where I gave the example of Zara's and how it uses postponement by buying white cloth in bulk, and then based on whatever the trend is in the market, it then right before a certain season, it will go ahead and dye or print the white cloth. This is an example of postponement customization. And so a lot of people, a lot of companies are doing this because, again, it's easier to forecast in the short run versus, the long run. So Zara's does not print and have all the cloth dyed in advance because it doesn't know what the trends are going to be. So it's smart to use postponement customization strategy, because that way you can change according to whatever is happening in the market. Now, after all of this, I'm going to be discussing, how to calculate forecasting errors. And this is also extremely important. So you can make, forecasts, but it's very important for you to continuously measure how accurate your forecasts are. If your forecasts are completely, biased, or they're not accurate at all, then you know that you're running into some sort of a problem. Either maybe your method of doing forecasting isn't correct, or maybe the data that your historical data that you're collecting to do your forecasting isn't correct. So it's very, very important to constantly be checking to make sure that your forecasting is accurate, and that the errors are very low, nominal as possible. Let's say, for example, this in this particular slide, these circles are the actual demand, or the what has actually happened in a particular period of time. Well, the question is, which of your forecasts is better? Do you think a forecast of these squares is better, where sometimes you're predicting lower, sometimes you're predicting higher, you see some sort of a zigzag um, uh, pattern? Or do you think it's better to just predict high, something, always predict higher than what is actually happening? And that's something I want you to think about. What do you think? Which one of these situations is better? Right? Um, and in the next slide, in the next couple of slides, I'll be talking about this. But when you're consistently always either over predicting or under predicting, that is called bias. You have a bias. And if, on the other hand, in this case, you're sometimes over, sometimes under, if you average this out, it's going to be somewhere in the center. So actually, if you had to decide which one is better of these two, I would definitely pick the squares. The squares is much better than the triangles, because the triangles, you can definitely note that they're always over predicting and there's a bias. And again, I'm repeating that the reason I'm saying squares is better is if you average this out, then it's going to be, very close to the circles. All right, so I've been, in the last couple of slides, I've been using two terminologies. I've been using the terminology of being accurate, and I've also been using the terminology of being biased. So it's important for you to understand what I'm talking about. Accuracy. So if, for example, this is a dartboard and you are throwing darts, you can see, somebody who's accurate is always going to be able to hit close to bullseye, whereas somebody who's not accurate is not going to be able to hit the bullseye. They're going to be hitting here, sometimes there, kind of all over the place. Now, so that is, what accuracy is: closeness to the actual observation, or closeness to your target. Your target is the actual observation. And if you can predict close to the actual observation, then you're basically hitting bullseye, which is very good. But if your predictions are really far away from the actual observations of what's actually happening, then you are not accurate, you are inaccurate, which is a problem. Now, also, something else that happens is bias. Sometimes what happens is, in this case, imagine somebody is hitting the dartboard and they always are kind of hitting in one particular area. It's a persistent tendency. Either they are, in terms of forecasting, they are either consistently under predicting or consistently over predicting. In that case, there is a bias. Consistent over or under prediction means that there is a bias, which is not a good situation. So in this particular dartboard, you kind of see that there's no bias. There's, they're going kind of all over the place. But here in this dartboard, you can definitely see that there is, a bias going on. So it's important for you to be very familiar with these terms. especially when you are talking about measuring error in forecasting. Okay, now these are a little scary when you first look at them, but I will break these down and I will explain them to you, and hopefully by the end of the lecture you will feel comfortable with these. So in a nutshell, all that this slide is really showing is various ways that you can measure the error between the actual demand and the forecasted demand. And, you know, these are just several ways. So on this slide, there are 6 different ways and formulas that have been given to measure errors in forecasting. And again, I'm going to go through each one of these and show you how to calculate the errors. And that will hopefully give you a much better idea. Okay, so I'm going to quickly go through, let's see here. I'm going to go through an example, and that should really help clarify the concepts. Okay, so here on this spreadsheet, I have basically cut and pasted the formulas, and I will be calculating, you know, the error using all 6 methods. And so hopefully you will get a good understanding of how to calculate the error and using all of these methods. So first things first, you know, we need to calculate the error. All right. And so what the error is, the formula is right here. Error is actual minus forecasted. So here I'm going to take the actual and I'm going to subtract it from the forecast. And I kind of want to have everything centered. So we'll sort of make it like this. And okay. So, you know, I've calculated the error now for Monday, Tuesday, Wednesday, Thursday, and Friday. So the first way I'm going to be calculating the error is mean deviation, right? So to calculate mean deviation, right, all you need to do is take the average of the errors. So these are the errors. I am going to take the mean deviation, I'm going to find the mean deviation. And so all I need to do is to calculate the average of the errors. And in this case, that comes to a 0, right? And so that's the answer. The mean deviation, surprisingly, is 0. Okay. Okay, next I'm going to try and calculate the mean squared error, or the MSE. Okay, so I'm just going to sort of say MSE here. And now, before I actually do that, I'm going to look at this formula. And by the way, this symbol over here that kind of looks like like an E, this is a summation symbol. And so this means sum of error squared. So I kind of, in this formula, realized that I need the error squared. So what I want to do is I'm first going to just calculate the error squared, because I'd like to have that information handy. And this, I'm going to be calculating the MSE. And so I'm just going to take the error and I'm going to square it. And this is how you square something in Excel, for those of you who don't know. And I'm just going to click and drag. And basically, when you do that, the formula is copied. And so this is, you know, -8 squared is 64, and so on and so forth. And the MSE is basically just the average of the error squared. So all I want to do is just take the average of all of this, and that gives me 126.8. So that is the MSE. Before I move on to mean percent error, I'm actually going to calculate the mean absolute deviation. Just make a little room here. Okay, so I'm going to calculate, so I was saying MAD, mean absolute deviation. And here, when I see that it's the, summation of the absolute error divided by n. And this is, in this case, it's 1, 2, 3, 4, 5. N is the number of instances. So it's 5. So here I kind of understand, I'm going to have to use absolute error. So I'm just going to mention that here just for me to remember. And so the way you can do that is you just, this is the symbol ABS, and ABS not of this but of the error, absolute error, and I click, I drag, and then I just take an average. Right, take an average, and so this gives me the MAD. Okay, next I'm going to calculate the RMSE, and this is just a slightly more complicated because we have to take a square root of the error, summation of the error squared over n. So it's similar to the MSE, but just a little bit different. So I'm just going to take the error squared here, and I'm just going to click and drag. And then for the RMSE, what I'm going to say is square root, and I'm going to say square root of the average. And so here we go. And this is the RMSE. Okay, next up is the, I'm going to now calculate the mean percent error, or the MPE. And this is just a little bit complicated because if we look at the formula, it's the summation of the error over actual, and you have to divide it by n. So here I'm going to take the error divided by the actual, okay, and I go all the way down, so, and then here I take the average. And so that gives the mean percent error. And finally, I'm going to calculate the MAPE, also known as the mean absolute percent error. And here I'm going to take the absolute error, summation of the absolute error divided by the actual demand, and I'm going to divide that by n. So what I'm going to do is I'm going to say absolute error divided by actual. I'm going to click and drag, and I am going to take the average of that then, like so. Okay, and generally for these kind of situations, you have to sort of read what the question says, but sometimes, it will say to 2 decimal places or to 3 decimal places. And so I'm going to sort of just make it to 3 decimal places. MAPE and MPE, the question may say give it in percentage. So usually it's for MAPE that the question may say give it in percentage. And if it says give it in percentage, then you just multiply this by 100. So if it says give it in percentage terms, this would be 20.8, the MAPE would be 20.8%. If it doesn't ask for you to give it in percentage, then it would just be 0.208. So, you know, I, through this example, have calculated the various ways of calculating errors, and I hope that this has been helpful for you. And you know, I will definitely be questioning you on measuring errors, because this is very important from a supply chain point of view, because you know, you do need to understand not only how to make forecasts, but to check for their accuracy level. Okay, now let's go back to our slides really quickly. And I kind of want to just touch on a few more things before wrapping up this session. One thing I do want to mention is that RMSE, out of all of these, is usually a good way to measure accuracy of a forecast. Also MSE. MSE and RMSE, these are the methods used to check the accuracy of a forecast. Okay, I've gone through the example with you. And in the next two slides, you can use this just to sort of check your understanding. This is just another example. And, you know, I highly encourage you to sort of take some time out and just, you know, cover up the answers and try and calculate the MAD, RMSE, MAPE, just to see if you've really gotten a good understanding of the concepts that have been taught in this class. And with that, I bring this lecture to its conclusion. I hope you have enjoyed the lecture, and I hope you have learned some new concepts. Thank you very much for your time, and I will speak to you soon.